Welcome. Today we'll be discussing topics in section 2.6, inverse tan, as well as examples. So for the inverse tangent, we will again use the similar notation of arctangent or tangent to the negative first. Again, this is tan inverse, as in an inverse function, not tangent to the negative first. And so the domain of arctangent is from negative infinity to infinity, and the range of arctangent is negative pi over 2 to pi over 2, exclusive of negative pi over 2, pi over 2. That is different from the arc sine, as it included the possibility of pi over 2 and negative pi over 2. As well as the domain of tangent is all reals, or from negative infinity to infinity, whereas the domain for arctangent, or sorry, arc cosine or arc sine was merely just -1 to 1 inclusive. So what are some properties that we have? We know that tangent and arctangent, so tangent of arctangent of any value is equal to that value. And this is specifically for any x. So x within all reals. And that's because of the domain of the arctangent. If we have arctangent tangent of some theta, this will equal theta when theta is within negative pi over 2, pi over 2. So we can kind of see that from how tangent function is, where we kind of have a copy of the period as pi, and we'll see this sort of image like this, and it repeats every pi. So we restrict ourselves just to the standard interval for the tangent. So the one that crosses the x-axis and the y-axis, or goes to the origin. And we can see some examples with this. So let's find the exact value of arctangents of negative square root 3. So the first thing is to think, okay, which quadrant could this be in? Because it's positive, or sorry, because it's negative, we know that it would either be in quadrant 2 or quadrant 4. And the angle output is somewhere between negative pi over 2 and pi over 2. So this is the range of our output for arctangent. And so that means we're going to be working with quadrant 4. So now we can write down, okay, tangent of what theta is equal to negative square root 3. Well, we know that tangent of pi over 3, that is square root 3. And so we can just take the negative version of that to get negative, because we know that the negative tangent of a negative theta is equal to negative tangent of that same theta. So we can insert a negative to have a negative output. And there's our answer. Theta must equal negative pi over 3. However best you can find this on the unit circle, if you knew that 5 pi over 3 was the correct answer as far as going counterclockwise, we can simply just subtract 2 pi or 6 pi over 3, and then we get our negative pi over 3, as we want to hit our target in the range of arctangent. So much like when we have a negative theta inside of a trig function, we can have a negative theta inside of an arctangent or a inverse trig function. And we have some properties. We have the negative formulas. And they are arc sine of negative x is equal to negative arc sine of x. Cosine inverse of negative x is equal to pi minus cosine inverse of x. Arctangent of negative x is equal to negative arctangent of x. And for each one of these, the first two, x has to be within negative 1 and 1. The second one, we have the same constraint of what x can be. And for the third one, x can be within all reals. Okay. This will be your check on learning for this video, is to restate these negative formulas with the restriction of what x can be. Okay, so what is another typical example that we'll see? We can say, find exact values of all 6 trig functions of tangent inverse of negative 2 with the terminal side in quadrant 4. Okay. So we could imply that it would have to be within quadrant 4, otherwise tangent inverse would be invalid. We couldn't find that. We'd have to make adjustments. But so with it being quadrant 4, we can now say, all right, what's our triangle looking like? Well, we got negative 2. So with a theta here, we must have -2 over 1. So the opposite is -2. So it'll be something like this, -2, 1. Our hypotenuse, I'm going to mark as h. We can solve for h and say that 1 squared plus -2 squared is equal to h squared. This gives us 4 plus 1, so we have 5 is equal to h squared. So then h is equal to square root 5. Note we're taking the positive value of this root as it's a distance, and so we're going to mark it as positive. And so now what we can say is this theta is brought about by this inverse tangent. So we can state that sine of tangent inverse of -2 must be the opposite over hypotenuse, so -2 over square root 5. Cosine of tangent inverse of -2 is equal to, and we get 1 over square root 5. Tangent of tangent inverse of -2 is equal to -2. And we can fill out the rest by taking the reciprocal of these values. So we can write cosecant of tangent inverse of -2 is equal to square root 5 over -2. Secant of tangent inverse of -2 is equal to square root 5. And finally, cotangent of tangent inverse of -2 would be -2 divided by square root, sorry, just -1/2. Looking at the wrong one. And with that, we have found all of the trig functions in relation to this angle. Note, we never actually found the angle of what tangent inverse of -2 is. It didn't matter because we're able to use the relationship of drawing a triangle and then being able to find a solution based upon the triangle generated by this specific angle. Thank you for watching and have a great day.